Okay, so this is just a quick lesson on basically how servers work or web files are accessed or given to a web browser. Now we have to look at a couple things. I'm going to use a whiteboard on this, so hopefully if you watch it in HD, we're going to be okay and you'll be able to see it. So we're going to try this out, see how this works. Normally this is something, of course, that I'd use a whiteboard in class for, but we're going to go with this, and hopefully you can hear me okay with this setup. But again, we're going to try it out, see how it goes. So, disclaimer aside, realistically what we need to talk about is when you're serving web files or when we're working on a website, something has to happen. Those files somehow have to get to that user's computer. So when they go ahead and type in google.com, for example, those files have to come from somewhere. And if you start learning about system administration, database administration, server administration, you're going to learn a lot more about this than what I'm going to teach you in the next 5 minutes. But I'm hoping that if you don't get into those, or even until you get into those, this is going to be a really quick primer for basically what's happening when we go ahead and serve what are known as web files. When we have a server, a web server that serves web files. Now, how it works is pretty much is there's two sides to this. There's the client side. Okay, we have the client side and we have the server side. Right? So the client side, that's our laptop, that's our computer, that's our web browser. We have our URL up here, and this is a laptop or something. This is the user's computer, and they've typed something in, and they've gotten probably to Google with a search box, right? So we have something like that. So there's our Google, there's our search box. That's our client side. Now our server is literally, and normally these computers are in a server rack. But they're a computer. They're a computer. That's what they are, right? They're a computer of some sort sitting somewhere running and serving up files. That's really what they are. So when I go ahead and go to a website, if I want to go to google.com, no one ever types a domain in like that. When I want to go ahead and go to google.com, what happens? So first of all, my computer is going to make a request. My computer is going to make a request to try to find where this website is. So this server here hosts the files. This is where those files are. So index.html is over here, right? Maybe I have an image.jpg. That's over here, right? Maybe I have an About Us page. Maybe I have whatever. It's sitting over here in a folder called Google. Okay, for example, just as a perfect example. Okay, so this is sitting in a folder. There's multiple files in this folder. There's going to be all kinds of files in this folder, but that's about it. So when the user goes ahead and requests google.com, they want to go to they're going to go to their web browser, and they type that into the address bar. What happens? Well, the first thing that the computer needs to know is, what is google.com? Where is it hosted? Where does it go to? When I type in that domain name, right? When I type in the google.com domain name, where does it go to? Well, most of the time, especially for google.com, your computer already knows. Your browser will actually cache where that is. So they'll cache it. Cache, not like cache as in money, but cache as in like basically a little file that exists that says, a little database that exists that says, google.com actually resolves to this server here on the internet, somewhere on the internet, which is a computer running an application that hosts websites, right? In this case, this computer is most likely a Linux computer, but it could be a Windows computer, could be a Mac computer. Most of the time it's going to be Windows, and most of the time it's going to run either one of two applications, which is just a piece of software on that computer that serves websites. Most of the time it runs one of two. It's going to run one called Apache, known as an Apache web server, or it's going to run one called Nginx. Okay? Now, that's if it's Linux or if it's Windows. Both will run on both applications, both and Mac as well, actually. Mac actually ships with a version of Apache built into a web server built into it, which is fantastic for web developers. Mac is actually a good web development application, but anyways, plug aside. What we need to look at, though, is if this is Linux or Mac, it's going to run these. If it's Windows, it could run these. But if it's Windows, it could also run what's known as .NET. Known as IIS, actually, is the technical term. Internet Information Services or something like that. I can't remember what IIS stands for, but IIS is a Windows-only web software that runs, sorry, desktop software that runs websites. That runs basically, it's a web server. It's a web server application. So when I go ahead and type in google.com and I know that I get here, that's what's responding. This application is what's sending the website back. Well, we'll get there in a second. So let's erase that for a second. And let's think about this domain name again. So this domain name, google.com, goes somewhere. It's got to go somewhere. And everything on the internet has what's known as an IP address. So the IP address of this server could very well be, and you're going to learn about IP addresses, I'm sure, if you haven't already. It could be something like 243.107.5.197. Could be a number like that, right? Could be something like this, just random number. I don't know whose IP address that is, but it could very well be that IP address. So this server has this IP address, which is like kind of like 123 Fake Street, Toronto, Ontario. That's your address. There's only one of those in the entire world. It's the same thing that happens here. This is the street address of this computer. There's only one of these in the entire world that has that number at that point in time, right? And that's how. And this is known as IPv4. There's also IPv6, which you'll learn, but let's not get there. Pretend I didn't say that. Okay, so we need to know if Google.com points to this. We need to know how that exists. So as I said, a lot of times that's cached by your browser. Your browser already knows where Google.com goes to. However, this changes. This number could change, or if I've never been to Google.com, I need to know this number. So what it does is it checks, first of all, your browser cache. If your browser doesn't have it, it actually checks your operating system's cache. So if you're using Windows, your operating system is Windows. If you're using Linux or Mac, your operating system is Linux or Mac. Then, if that doesn't have it, it checks your what's known as your ISP, which is your Internet Service Provider. So your Internet Service Provider will actually have a cache of domains. It'll have a domain cache, so it'll know, hey, that's google.com. If for whatever reason it doesn't have that, it's going to keep looking and looking until it finally gets to the service that has it, that actually has that that worldwide domain name that exists, that cache. But anyways, and again, you'll most likely learn more about this in your network class. I don't want to step on any of those teachers' toes, but I just need you to understand the very basics of how I get there. We're not actually going to be talking about domains in this class, so we're not going to be talking about how to get to buy a domain or anything like that, but that would be really what this is about, right? It's buying a domain and pointing your records to the web server. But either way, let's pretend for a second that this all exists. This is all fine. I know I go to google.com, my computer knows to go to this server. That exists. That already happens. Perfect. Now, what happens next? Well, I need to somehow get that website on the screen of my computer, right? So when I go ahead and type google.com into the web browser, and I know that google.com is pointed to this, I make what's known as a request. Let's see if this color looks okay. It doesn't even work. This marker doesn't do anything. So I make what's known as a request. I'm going to need more colors in the future. So this request is, I basically go to here and I make a request known as an HTTP request. Okay? Happens to be the protocol that I'm using is the hypertext transfer protocol, which is the HTTP protocol. Because technically speaking, I'm not going to google.com, am I? There's a glare on the screen, so I'm going to move this over. I'm not going to google.com. I'm going to http://google.com, right? Just my browser is going to auto add that protocol piece. But this is the protocol that I'm using, the technology that I'm using. So I make an HTTP request to the server for google.com. The server then says, okay, what do I have for google.com? It's going to go to the file folder on its computer. On the computer, the server has a computer, it's going to go to a file folder there on its file system, and it's going to find a Google folder that it's been mapped to, and it's going to say, well, I have an index.html file, and by default, I'm going to serve that first. So what does it do? It sends it back as an index.html file. And then that index.html file starts to load on your laptop. The story's not done yet, though. We've pretty much if that was it, if that's all that existed on this website, then it's done. There's not really anything else that needs to happen. But, for example, this index.html file has this Google image, right? It has a Google logo on it. Well, that didn't come with the file. I only got index.html. So it's going to start looking at that index.html file, and it's going to come to a image HTML element with a source that's equal to image.jpg. Right? And we're going to talk about images. So if you haven't watched the lesson about images just yet, then you need to go back and go to that one. But realistically, this piece here, it's going to hit that. It's on one of the lines in that index.html file. So all of a sudden, your browser is going to go, whoa, I need another file. So how's that going to work? Well, it's going to go ahead and make, you might have guessed it already, another request. It's going to make a request now for that image.jpg file. And then that's going to get sent back. And it's going to keep doing this. If there's CSS files, if there's more images, if there's JavaScript files, whatever it may be, it's going to keep sending them back and forth, right? I'm going to make a request and say, hey, server, I need this. It's going to send it back. And it actually has to do this one at a time with the 1.0 version of HTTP. However, we now have a 2.0 version of HTTP called, or otherwise known as H2, because HTTP 2 is harder to say, so they just call it H2. So H2, where actually all of these can download concurrently. So I can actually start making the requests, and while I'm making those requests, it can send all those files back. But previous versions of the HTTP, or the HTTP protocol, only allowed them to download one at a time. So websites were actually a little slower back then. But that's helped a lot. However, all of this happens in the background. So when I go ahead and type in google.com, just as a quick recap, what happens is my computer needs to know what google.com is. It has to go look that up, right? So if I've never been there before, if my computer's never been there before, if my internet service provider's never been there before, it needs to go out on the World Wide Web and find that. Once it's found that domain name, I now know where to go. So I can make a request to that server. That server all of a sudden boots up. Ooh, all of a sudden there's a new process. We're now loading a new website. It's going to go ahead and grab that website and send it back, right? And then I need to say, oh, I need another file. Okay, I need another file, and back and forth. And all these things happen within a mere seconds. Otherwise, if I'm loading that up, especially on my phone, because people have like unreal expectations of how fast things should happen on their phone. If I'm loading that website up on my phone and it takes more than a few seconds, I'm going to be like, I don't know, it's garbage. Phone's garbage, need a new one. Or I have terrible service or something, right? And they get really frustrated. So things need to happen really fast. So all of these things are actually extremely efficient and happen within milliseconds. This whole domain name lookup thing happens within milliseconds, and me starting to make that first request should happen within milliseconds, because otherwise it's going to make it a lot slower, right? And as you can start talking about performance, server performance, we start getting into that. We say, okay, how can we make, of course, I can't make the request happen any faster because that's based on my client's computer, but once that request comes to my server, how fast it takes for my server to send back a file is something I can fix. How fast it takes for this image to download has to do with my server's connection as well as the client's connection, but I can fix maybe the server's connection, and so on and so forth. And I can optimize things. If this image is too big in file size, I can make that image smaller and it'll go faster, right? And there's lots of things I can do. If I have CSS files, I might have multiple CSS files. If I can put them all into one file, it means I make less HTTP requests. That's going to speed things up as well. So there's a whole bunch of these little performance things that we can do to make this process faster, in which case makes your client's users, or your client happier, right? The client side, the client being the user that's going to your website. Now, another quick aside to this is we also have programming languages that are known as client side and server side. And we're not going to talk about any server side ones this semester. You're not going to learn that. But if you take computer programming, you would. Because a lot of websites are powered using what are known as both client side and server side languages. Now, if you haven't guessed yet, the difference between a client side language and a server side language is that a server side language is processed on the server and the client side language is processed on the client. So, for example, HTML is actually known as a client-side language. The file is sent verbatim, straight up, from the server to the client, non-processed. And then your browser processes that HTML file to display it in the browser, right? CSS, same thing. It's sent verbatim from the server to the client, and the browser processes it. JavaScript, the world's most popular server-side language that can do most of the web, right? A lot of things on the web. This all happens client-side. with the exception of what's known as Ajax. Ajax is known as asynchronous JavaScript and XML, and really what that is a way for JavaScript to communicate back and forth to the server, to make requests for new information. So this enables things like Facebook, for example, to be able to say, okay, when I do something on the screen and press enter, nothing has to refresh. I don't need to get a new index.html file. I'm just going to get a little blob. I'm just going to update just that tiny little piece of that website in there. Ajax allows that technology to exist, or for that feature to exist, right? It's the technology that does that. We're not going to learn about Ajax, and we're really not going to learn about JavaScript, but it's important to understand that these are client-side languages. Ajax is technically a client-side language, but it almost sits in the middle because it allows more things to come down from the server. A perfect example of a server-side language is actually an open-source language that powers most of the web, known as PHP. We talked about PHP the other day and what it stands for, which is ridiculous, and I'm not going to go through it, but it's it used to be called Personal Homepage, but now it stands for PHP something processor. Like it's weird. It's got like PHP's part of what it stands for. It doesn't matter. I don't want to get into it, even though I did. So PHP is a server-side language. So what that means is that this is actually processed at the server. So there's a bunch of code that's written over here in this PHP file, and what actually gets spit out, believe it or not, is essentially an HTML file. So it processes and creates the page that you then see. Right? And that sounds a little confusing for now, but if you ever do get into computer programming, this starts to make a lot more sense. But how fast this file runs and how fast these files run completely are based on two different things. This one is running on the server. So the computer power of this server, the performance of this server, and the optimizations you've made to it is what's going to make this run faster before it can serve that file, the outputted HTML, if you will, to the client. These files, your HTML, your CSS, and your JavaScript, that's up to your client computer to figure out how fast it can run it. Now, you can make optimizations as the programmer in this case, write more efficient code. Less code, for example, to do the same thing is more efficient most of the time. So if I write more efficient code here, that's a way I can speed this up. But at the end of the day, if this is a really old computer and I have some complex JavaScript happening, it's going to take a long time because it has to do that work, right? Or if it's a really fast computer. So again, I can't control this, but I can control the efficiency here, and I can control the power here and the efficiency here, if that makes any sense. So again, quick aside on all that, but realistically, this is what we're talking about this semester. That's it. We're talking about these two languages, HTML and CSS, and we're going to do all client-side programming, I should say, but we do need to understand where those files are coming from. So that's it. If you have any questions, hit me up on Teams, and we can go from there. But other than that, that's it.